Hey guys, let's talk about the easiest factoring lesson, and it's just when we use the distributive property. So basically, if I want to factor a binomial, I'm looking for the greatest common factor. The GCF of 12 and 8 is 4. If I've got x to the third and x, I can factor out just one x from both of those terms. If I have y squared and y, I can factor out just one y from both of those terms. And then I do the distributive property backwards. Let's see, 4 times 3 would get me 12. X times x squared would get me x to the third, and then y times a y would get me y squared. So then 4 times what is negative 8? Okay, negative 2. And then xy is already there, so I don't have to put any xy at the end. Now, if it's a trinomial, it has to be stuff that's in all three terms. So 12, 8, and 6 are all divisible by 2. I can factor just one x out from each one of these three terms, but I notice I don't have a y in all three terms, so you cannot factor that out. 2 times 6 gets me 12. X times x to the second would get me x to the third, and then y squared. 2 times negative 4 is negative 8. And then I already have an x, I just need a y, and then 2x times 3 would get me that 6x. Now, when you have a 4-term poly, you don't do the whole thing. You actually split it up into 2 halves. So you find the GCF of the first 2 terms. For GCF here would be 2x. I factor that out. Great, I'm left with x plus 3. Then I go ahead and I do the same thing for the second half. The greatest common factor of x and 3 is just 1. They have nothing else in common except for a 1. And I'm going to notice that what's in my parentheses is the same as before. X plus 3, twins. We call those twins. It's actually a self-checking point. The GCFs go into one part of my factored form, 2x plus 1, times one of my twins, x plus 3, and there you go. You have it. Good job.